Well, hello, everybody. It's Thursday, March 4th, and today's a glorious day. Today, you're going to start to draw covalent bonds. So, we spent some time drawing ionics. Well, we're switching gears. We're headed into covalent stuff, and we're going to start drawing those. You do need to pay close attention here because covalent bonds are drawn in a different way, like completely different than ionic bonds. So you want to pay attention. You don't want to confuse the two because they're drawn totally differently. All right. So I'm going to do this first example for you, and then you can take a look at the next slide and try that one out on your own. All right. But for this first one, we're going to make a covalent bond between one oxygen and then two hydrogens. All right. One oxygen, two hydrogens. All the things you'll be using are up here. I put it in this little red box and labeled it tools because these are the things you'll need to work. All right. So we're going to need, we're making it with one oxygen and then two hydrogens. So over here, the instructions lead you through this. All right. And I'll work through it with you as well. So first thing we need to do is create Lewis dot model for each atom. Okay. Now a few things to think about though. If there are different elements, like there are with us, we got oxygen, we got hydrogen, so different elements. The one with fewer atoms goes in the center. Okay, the one with fewer atoms goes in the center. Other times you might think about it this way. If it needs more valence electrons than the other, or it needs more dots, that one's going to go in the center. So for this case, the one that we have fewer of, so we only have one oxygen versus two hydrogens. So we're going to put oxygen in the middle because there's only one of them. There's two hydrogens. So I'm going to drag an oxygen down here, and then I'm going to place a hydrogen on either side. Just like that. Okay. Now the other thing to think about, like I said right here, if it needs, whichever one needs more dots, that's what usually will go in the center. Well, oxygen's over here in column 6. It's got 6 valence electrons, 6 dots, so it needs 2 more to get to 8. Remember, hydrogen's a little different though. Hydrogen only has 1 dot. It only needs 1 more because it's so small. It only needs 2 because it only fills up that first ring, if you remember. So hydrogen only needs 1 more. Oxygen needs 2 more. So the way I look at it is that oxygen needs a little bit more help. So we gotta put some helpers around oxygen so that it's gonna get enough valence electrons. It'll get enough dots. So we put oxygen in the middle because there's fewer oxygens than hydrogens, and oxygen just needs a little bit more help. All right, now we're going to place some electrons. Okay, it says place single electrons on the sides nearest other atoms. So we'll put the pairs kind of away from other atoms. I'll show you what I mean by that. And use different colored dots for each atom. There we go. Use different colored dots. All right, for every atom. So I have 1, 2, 3 atoms. 1, 2, 3. So I'm going to use 3 different colors. All right, here we go. So this hydrogen over here, remember, like I said, hydrogen's in column 1, just needs 1 dot. Hydrogen over here, same kind of hydrogen, only needs 1 dot. I'm going to use red. You can use whichever color you like. But I'm going to put the dot over here. I'm putting it on the inside, not like we've made Lewis dot models before. I'm doing a little bit different, and you'll see why in a minute. But I'm doing that because that's what it says right here. Place single electrons on the sides nearest other atoms. Okay, so we do things a little bit different because in the end, it's going to be a little easier for us, and you'll see why. All right, and then we got oxygen. Oxygen is in column 6, so it's going to have 6 dots. I'll use blue. So we'll start with 1, and then 2, 3, 4, and then before I start doubling up on the side, you got to remember what it says here. Place the singles on the sides nearest other atoms. We want to put the pairs of electrons away. So I got 4. Remember, it needs a total, it starts with 6. So I'm going to put the other ones over here and then right here. So that's how it's going to look. If I can drop that thing down. There we go. Ah. Oh. Okay. All right. This is an issue. There we go. Whew. All right. Oh, I don't like that though. Look at that. That's nasty. Let's get this little whippersnapper over. Beautiful. Okay. So I put it like that for a reason. And you'll see that in just a second. But no, so notice I put the singles nearest the other atom. So this single electron I put near this hydrogen. This single I put it over here. Normally we would have put these electrons in a little bit of a different order, but it's going to help us out in this next step. So that's why it's easiest if we do that. Because now this next step says we need to connect single electrons of different atoms with a gray stick. Okay, with these gray sticks that I have up here. Okay. You got to remember what covalent bonds are. Covalent bonds are when nonmetals share valence electrons. They share them, right? They don't totally give them up like in an ionic bond. They share them, right? So they kind of just say, "Here, this is mine, but I'm going to pass it over to you, every so often, so that you satisfy the octet rule. As long as you do the same with one of your electrons, so that I follow the octet rule, I satisfy the octet rule." So what we need to do is we're going to take one of these gray sticks and we're going to place it over and we're going to connect single electrons, because what that's going to show is a bond. It's going to show that they're sharing those valence electrons. All right. So those sticks, those bonds, they represent two shared electrons. Okay, those sticks represent two electrons that are being passed back and forth between those atoms. Okay, so at this time we're pretty much done with our model. Okay, but we want to verify that everything checks out and everything looks peachy. So we want to confirm that everything has the electron amount that it needs. Remember, most things want 8. Hydrogen's the only exception. It's only going to need a total of 2. Okay, so here we got oxygen. Oxygen's got the 1, 2, 3, 4. But remember, this stick now represents 2. So that's 5, 6, and then over here, 7 and 8. So oxygen looks good. Oxygen looks great. Hydrogen. Hydrogen only has that stick coming off of it. It only has that bond coming off of it. And remember, that bond represents 2. Well, guess what? That's all hydrogen needs. So hydrogen's got what it needs. And same with this one over here. Perfect. It's got the 2. So everyone's happy. Everyone has what they need. So we can move on to the next and last few steps. We got to write a formula and a name. Okay, so a formula and a name. Formulas are kind of weird. There aren't really any set rules on which letters or which element is written first. So sometimes I'm just going to give you the formula because it's going to be easier for you. But with this one, I'll kind of walk you through this one, I guess. We got 2 hydrogens, right? So it's H2, and we only have 1 O. So just O. Remember, you don't need the 1 right here. Don't need that 1 because we wrote the letter. So there must be at least one of them there. So we don't need anything else. So, what do you know? You probably recognize that. H2 and then O. Now, you and I know that just to be water. But covalent compounds are given technical, chemistry or chemical names. And so jump down to slide 3 to see how we do that, because there's a little bit of a procedure. Some of it's going to be similar, but some is new. So when you name these things, the first element gets a prefix. All right, we got all these Greek prefixes down here that indicate amounts. So the first element will always get a prefix, or I'm sorry, hang on. The first element gets a prefix added to the front only if there's more than 1. So for our example, what we're doing right now with H2O, we're going to give H a prefix because there's more than 1. There's 2 of them, right? There's 2 H's, 2 hydrogens. But in another example, like with CO2, that doesn't get the C, the carbon there does not get a prefix. If you're familiar with CO2, that's carbon dioxide. There's no prefix on the carbon. It's just carbon. But for what we're looking at here with hydrogen, we are going to give hydrogen a prefix for 2, and that's di, di. So we'll come back up here, and we're going to type in dihydrogen. And then we got to come up with a special name for the oxygen. Well, if we come down here, we see the prefix for just one is mono. And so we're going to come back up. We're going to use that prefix mono. Oop. And it just ends up being monoxide. Because we do add an ending onto the end. We add that "ide" onto the end. Just like we did in ionic, you add the ending to the second element. All right, you add the ending to the second thing. Naming these kind of takes a little practice, because a lot of times people would want to write like monoxide because they think there's going to be two O's in there. So it takes a little, sounding out, kind of like the naming and everything we did with ionic was the same. Okay, but this one ends up being dihydrogen monoxide. So, from a chemical standpoint, water is technically known as dihydrogen monoxide, but a little easier if we just call it water. But that's how you do that. Make sure that you follow these instructions closely. Click back to watch this video if you need a hand later on. Come to class, come to office hours. Code to join office hours is Delfeld office, one word. After school, 1:20 to 2:25 every day. Um, Let me know if you need any help. Try the second one, and then we'll get more practice in the coming days.